Assalamualaikum and hi everyone. Firstly, we sincerely thank Dr. Siti Haja binti Alias, our lecturer, for her guidance throughout our video assignment. So today, we will present about gravimetric analysis in agriculture. Enjoy our video.
Our group consists of 4 members, which are Rahmatul Nadia, Nuralia Natasha, Nur Farisha Akilah, and Muhammad Zahin Al-Muiz. I'll pass to the first presenter.
What is gravimetric analysis? A quantitative method used in analytical chemistry to determine the quantity of a substance in a sample by its mass. Use the concept of weighing and precipitation to separate and evaluate the target. Used in environmental monitoring, pharmaceutical analysis, agriculture, and quality control in industries such as food and beverage. There are 2 types of gravimetric analysis: volatilization gravimetry and precipitation gravimetry. In volatilization gravimetry, we separate a volatile component from the sample by heating it. It is useful for substance that can be vaporized under certain conditions. For example, a solution of sulfuric acid can help separate carbon dioxide gas from sodium bicarbonate. In precipitation gravimetry, a specific reagent is added to the analyzed solution to form an insoluble precipitate. The precipitate goes through several stages. It is filtered, dry, wave to evaluate the quantity of the analyte in the original sample. The steps in gravimetric analysis are as follows: preparation of the sample, precipitation, filtration of the precipitate, washing of the precipitate, drying of the precipitate, weighing of the precipitate, and finally, data calculation. Each step must be performed carefully to ensure accurate and reliable results.
Let's talk about the advantages of gravimetric analysis. First, gravimetric analysis does not need expensive or sophisticated equipment. Second, it can minimize instrumental error, which offering a reliable data and result. Lastly, it provides highly accurate and precise analytical results when performed carefully. Now, let's look at the disadvantages of gravimetric analysis. First, gravimetric analysis is mostly a time-consuming method because it requires a lot of time. Second, it only provides a single element or limited group of elements at a time when analyzing it. Lastly, gravimetric analysis can be complex and might cause minor errors that lead to unreliable data. Next, I'll talk about precision in agriculture, the role of gravimetric analysis. Determination of sulfur content in fertilizer using gravimetric analysis. Sulfur is an important nutrient that need for a plant to grow and develop. For example, ammonium sulfate in fertilizer. Figuring out the amount of sulfur content in the fertilizer is important to guarantee the effectiveness and quality. Sulfur play a key role in plant metabolism, especially in the formation of proteins and enzymes. A deficiency in sulfur could cause to yellowing of young leaves and stunts their growth.
Why do we need to determine sulfur content in fertilizers? Firstly, determining sulfur content helps improve crop yields as sulfur in fertilizers promote healthy plant growth. Moreover, sulfur-containing compounds enhance plants' natural defenses against pests and diseases, which decrease the reliance on pesticides and fungicides. Additionally, sulfur improves the availability of key nutrients such as nitrogen and phosphorus, leading to healthier plants and increased nutrient uptake. Finally, sulfur is crucial for synthesis of oils, making it especially important for oilseed crops. Now, let me explain the procedure to determine the sulfur content using gravimetric analysis. To begin with, weigh about 2.0 grams of the fertilizer sample and transfer it into a beaker. Next, add 100 milliliters of distilled water and stir the mixture thoroughly to dissolve the sample. After that, filter the solution to remove any insoluble materials and rinse the residue on the filter paper with distilled water. Collect the filtrate carefully. Then, transfer the filtrate to a 250 ml beaker. Slowly add 60 ml of 0.10 ampere chloride solution to filtrate while stirring continuously. This will result in the formation of white precipitate of barium sulfate. Subsequently, collect the precipitate by vacuum filtration using filter paper. After filtration, leave the filter paper with the precipitate to dry in air for 24 hours. Finally, weight the dry filter paper along with the solid precipitate and record the mass of the barium sulfate obtained.
And this is the example of result. You guys can take a look. So now we're moving on to the calculation. So these are the equation of barium sulfate. Barium sulfate we break down into Ba2 plus and then plus SO42 minus. So next is a calculation of gravimetric factor. So Rm of sulfur will divided by RMM barium sulfate, which is 32.07 gmol divided by 253.40 gmol, which is 0.1374. So next is moles of sulfur. To calculate the moles of sulfur, we must take mass of sulfur divided by RMM of sulfur, which is 0.441 gram divided by 32.07 gmol. Thus the calculation is 0.01375 mol. So next, we're going to calculate of mass of barium sulfate. To calculate this, we must take mass of dry filter paper plus precipitate and then minus with mass of dry filter paper. So the mass of barium sulfate, which is 4.44 gram, will be divided by mass of dry filter paper, which is 1.345 gram. Thus the calculation is 3.209 gram. Alright, next, to calculate the mass of sulfur, we include mass of barium sulfate multiplied by GF, which is 3.09 gram multiplied by 0.1374 gram. And the calculation is 0.441 gram. Next, the percentage weight of solid over weight of solution of sulfur in the fertilizer samples, which is 0.441 gram will be divided by 2.01 gram and then multiplied with 100, which is 21.91%. Right, conclusion. Gravimetric analysis is a quantitative method that is based on determining the mass of a compound to which the analyte is chemically related and no standardization of solution is required. This method selectively converts the analyte to an insoluble precipitate, which the precipitate is then dry or ignited and accurately weighed using analytical balance. There are two types of gravimetric analysis, which is the precipitation gravimetry and volatilization gravimetry. All of this method has the same purpose, which is to separate the analyte so it can be weighed. There are also 8 steps of gravimetric analysis, such as preparation of solution, precipitation, ligation, filtrating, washing, drying or igniting, weighing, and calculation. Overall, gravimetric analysis is a cost-effective method of analysis since it didn't require expensive requirement or reagent. Application of gravimetric analysis in real life can be very useful, such as agriculture. So these are our reference. You can take a look here. And thank you. That's all from us.